You're listening to Science Coast with Mallory Havens and
Chris White.
And today our guest is Dr. Joe Kozminski, chair of the physics department. Can you tell me what kind of physicist you are? Because I'm surrounded by physicists right now.
Yeah, so my training's in high energy physics. I did some work at Fermilab, but I've transitioned my research to climate vulnerability inputs, things like air quality, urban heat islands, and
Yeah,
such.
but you did quarks.
I did quarks. Yeah, my PhD was on the top quark.
Leptons roll, man. Leptons roll.
I'm surrounded by physicists.
Okay. That is actually a true statement. We're going to continue our sustainability series of podcasts, and we're going to today talk about whether such a thing as sustainable energy exists. As a quick reminder, there's different ways that you can think about sustainability, and in past shows, there have been different definitions about what sustainability means. And I'm just going to say today that sustainability means that you can do something forever. Well, not technically forever, but for a very long time, without there being, potential, negative impacts that make it unsustainable.
So living off the interest
living
rather
off
than
the interest,
taking out of the principal.
Or making your grandchildren pay back debts that we take out today.
Right. I think I don't have any of those. Grandchildren.
Oh. I was trying to think.
I wasn't talking about my personal finances.
Yeah. Student loans? What are we talking about here? So energy. We get our energy from many different forms. And if you think about fossil fuels, oil and coal, natural gas, it is a finite resource. We can have a nice conversation about how much actually exists, but I think everybody would agree that if we continue to use fossil fuels, there will be a point in the future when there isn't much left.
Or any.
True.
Yeah.
Or not accessible.
So,
right.
Or not accessible. That's another way of saying it. It'll be, economically not viable to continue to obtain these fuels. So that's an example of something which is unsustainable. So then the question is, are there other fuel sources that are sustainable? People talk about wind as being sustainable, wave as being sustainable, tidal energy as being sustainable, solar energy as being sustainable. But one of the challenges and the things that's been bothering me as I look into these topics is that the tools that we have to build as a society in order to harness these energy sources may not themselves be sustainable. If you want to harness the energy from the sun, you have to build solar panels. So can we indefinitely continue to manufacture solar panels at the scale necessary to provide the energy that we need as a society, as a world of human beings?
And are there precious resources in solar panels, like, I don't know, lithium? I mean, I don't think there's lithium in there, but...
Dr. Kozminski, what would you like to say about that?
Yeah. So, I think that's a great question. The sources themselves are renewable, are sustainable. We're going to have sunlight for the next 4.5 billion years. That's well after my lifetime.
I don't think I'll be here then.
Yeah, I don't either.
I'm not sure humans will.
Very true. Gravity is going to be here for a while, so we'll have waves and tides.
Provided the oceans still exist.
Also true. And the Earth's core is going to be hot for even longer than the sun is going to be here. So we have geothermal. So the sources will be there. But I think this question about things like solar panels is a good one. Right now, we don't have the ability to recycle solar panels and the materials within them. And there are rare earth elements in solar panels. So if we aren't able to develop those technologies, solar panels could be a limited resource.
And about what fraction, do you know what fraction of the energy in the United States is coming from solar panels as it is?
Oh, not off the top of my head.
Magnitude.
Renewables are on order of magnitude 15% or so.
So if we're getting 15% of our energy from renewable energy sources, and we want to scale up to get 100% of our energy from renewable energy sources, we have to manufacture a lot more of these solar panels. But you just said
Absolutely.
that solar panels aren't recycling. We're not recycling old solar panels.
Right, and that's an issue with a lot of the renewable energies and the storage for electricity. We're not recycling solar panels, we're not recycling wind turbines, and we're not able to recycle the batteries at this point.
Do you have any understanding of why?
I think a lot of it's economic factors. It's expensive, and I think there's work being done on a small scale, but it hasn't been scalable yet economically.
Yeah, because if you don't have a battery to store your solar energy, then you kind of just lose it, right? Supposedly it can go back to the power company somehow a little bit, but it has to be used right away without a battery.
Did you see this article recently where they were talking about using lakes as batteries? So it depends on what you define, how you want to define a battery. But it's not as efficient as storing the traditional electric battery, where you convert energy into electricity and then store it in a battery, is typically what people think of. This article was talking about using excess energy to pump water up into a lake. And then when you want to get that energy back, you open up a hydroelectric, flue of some kind and use a turbine as the water flows back down to generate the electricity and convert it back into a useful form again. I don't think it's highly efficient, but it is possible. And in fact, I think there have even been these interesting storage devices where they have these train tracks that go up a hill. And so you have a plateau and you have these very heavy rail cars. And then when there's excess energy, you use that excess energy to push these very heavy rail cars up to the top of the plateau. And then when you want to get that energy back, you can let them roll down the hill and then capture the gravitational potential energy in a way which allows you to generate electricity.
So you're talking kinetic to potential to kinetic energy?
And electrical energy.
Yeah.
And the concept that that's a battery?
Yeah.
Was
it's an energy storage.
It's an energy storage, sure. Yeah.
Craziness. So, Dr. Kozminski, are you aware of or do you know, can you share with our listeners the types of materials that are needed to create the tools like solar panels and, wind turbines and things like that?
Yeah, so there is most solar panels right now are silicon based, and we have plenty of silicon. But there are no.
I don't know where silicon comes from.
Silicon comes from things like sand.
So sand is primarily silicon.
Yeah.
Okay, cool.
But there are a number of rare earth elements in the electronics for the solar panels and connectors and things. So those are the places where that we need recycling technologies for. And if there's a way to recycle the silicon, that'd be great also.
Is there what is the energy cost to make a solar panel? Does it take, 10 years? Not just the financial cost of buying one, but to physically put it together. I'm sure that's not carbon neutral. You have to harvest the rare earth elements. You have to have a factory putting all that stuff together with energy to make them. So does it pay for itself in 10 years or?
So, there certainly are costs to making the solar panels. We need to get those factories on renewable energies as well. But I think the mining is an interesting discussion as well, right? There's a human cost to that.
Yeah.
A lot of those rare earth elements are only found in certain places on Earth. And the mining technologies aren't always, the most equitable, and there's a kind of human capital that is used.
Like blood lithium, like blood diamonds.
Yeah.
And it's also true that I started with this analogy that eventually we will have taken all of the oil out of the ground and burned it. Is that also true with rare earths? I mean, is there a limited supply in the surface of the earth?
Yeah, there is. So they're only found in certain places, and there is a limited supply.
So we'll have to go after the asteroids after all.
Well, and you have to ship the rare earth from where it was located to where it's going to be used in manufacturing, which I'm sure is using fossil fuels and like cargo ships.
So you're saying that there's a carbon footprint associated with solar energy, but solar energy is just the sunlight. It's like,
You have to capture the sunlight.
Yeah, unless we're doing photosynthesis.
can we do that?
As humans, as individual, our bodies cannot, but we could.
Could you genetically engineer me to have like chlorophyll in my skin?
It's too late.
Too late?
But I don't know. I feel like, could we harvest photosynthesis to store the energy in like organic compounds and somehow use that to fuel? I mean, I guess that's the whole basis of biofuels, right?
See, that would be, we're talking about sustainable energy sources. Potentially, that's a sustainable energy source where you use the sunlight to do something organic, biological, which is completely recyclable. Wow, I hadn't thought about that. So maybe we can create some type of photosynthesis that generates energy.
And there are some dye-sensitized solar cells, not terribly efficient yet, that use things that kind of mimic photosynthesis to capture energy.
I just realized that what we're talking about is wood.
That's not the photosynthetic part of the plant, but yeah.
No, but that's the product. That's the consequence of the photosynthesis is that you grow a tree.
Some of it. A lot of photosynthesis is done by algae and bacteria.
What's an algae?
An algae is a protist, so it's.
What's that?
So,
remember, we're talking to physicists,
two physicists
here.
here.
So, in the kingdoms within eukaryotes, so cells that have compartmentalization on the inside, there's plants, fungi, animals, and protists. And protist is just a catch-all for everything that isn't fungi, plant, or animal. So, yeah.
Could we do a podcast on that?
We could.
Okay. I think I need to learn something more. What were we talking about?
Using biofuels from photosynthesis to maybe actually be sustainable. I guess you could make hydrocarbon chains, right? Which is the whole basis of combustion, but then you would still have the carbon footprint of combusting them.
But isn't that a cycle? If you're growing switchgrass and then you use the switchgrass to create a fuel and then you burn it, the fuel, and then the fuel goes back into the atmosphere, the carbon, but then the carbon goes back into growing switchgrass. Is that a cycle?
Yeah, that is.
Does that work, Dr. Kozminski?
Yeah, I don't know if that's fully carbon neutral. My guess is that it's probably not, but it is certainly better than digging coal out of the ground and burning it.
So if we were to grow our energy and use photosynthesis, water and carbon dioxide, to grow carbohydrates that we then burn to release energy, and then it goes back eventually to water and carbon dioxide, that is potentially a more sustainable cycle than what we're doing right now.
Yes, and a cleaner burning cycle also.
We should do it. We should somehow make plants make fats instead of carbohydrates. Because hydrocarbon chains
like
store
oils?
them. Yeah, well, they do make oils, so yeah, I guess. But like hydrocarbon chains are much more energy dense than sugars because they're hydrophobic, so they don't pack with water, so you get more energy per unit of mass.
So if we could find biological systems that take the energy from the sun and convert them into fats,
Oils, yeah.
And then we extract those fats and oils from the plants and then use them as a fuel. And then when we burn them as a fuel or use them as a fuel, they get broken back down into the carbon that goes back into the atmosphere. But then it's just a
cycle.
A virtuous,
did we just cure the energy crisis?
I think we
is it a
solved the
virtuous
problem.
cycle? Is that a virtuous cycle?
I'm pretty sure people are working on this.
I think the issue then is just scale.
Right.
And we use so much energy. And maybe you could, as a final word for this podcast, talk about the amount of energy that, what is the scale of the issue that we're talking about?
And in the United States alone, it's a huge amount of energy that we consume every year. It's on the order of 100 quadrillion BTU per year.
Right. What's a quadrillion?
So one quadrillion is a 1 with 15 zeros after it. That's roughly the equivalent. So one quadrillion is roughly the equivalent of 8 trillion gallons of gasoline, the energy content of that. So think about how many times you'd have to go fill up your car at the gas station.
And what's a BTU?
British thermal unit.
Okay, but that's actually, a BTU is the amount of energy needed to heat 1 pound of water by 1 degree Fahrenheit.
Yes.
Why don't we use the metric system for that?
I don't know. Because the British didn't invent it.
Oh, that's true.
I don't know.
So to a pound, I guess.
And we still use feet in the United States, so we're stuck on that imperial system.
Right. Which wasn't a foot originally based off the length of the king's foot?
I think so.
I think so, but I don't know.
I'm not sure I care. Anyway.
So sustainable energy is not yet sustainable because of the manufacturing processes and lack of recyclability, but we're working on it?
Yes.
Okay. Give us 100 more years. You've been listening to Science Coast. The views, thoughts, and opinions expressed are the speaker's own and do not represent the views, thoughts, and opinions of Lewis University. The material and information presented here is for general information purposes only. The Lewis University name and all forms and abbreviations are the properties of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service. Looking at you, solar panels. This product was produced in the WLRA podcast studios at Lewis University. Visit lewisu.edu for more information about Lewis University. So this is Mallory Havens.
And Chris White.
And
Joe Kozminski.
Thanks.
Bye.